Welcome back, students. I am your geography teacher Vandana Joshi and you are watching SST June. Students, in the previous video of the chapter Distribution of Oceans and Continent, we have studied about the distribution of continents and the distribution of oceans, where we have studied the continental drift theory of Wagner, which is proposed on the basis of the continental distribution. In the last video, we have studied the Hayes theory and Morgan's theory, Mackenzie's theory, which is telling us about the sea floor spreading, and the plate tectonic theory, due to which the oceans were distributed. And combinedly, these theories are also telling us about the distributions of the oceans and continent. In today's video, we are going to study something more about the distributions and the spreading movement of the oceans and the continents, where we will see today the rates of the plate movement, the forces behind the plate movement, and for the example, we will study the formation or the plate movement of the Indian plate towards to the northern portion, where it was merged with the Eurasian plate. So let's see our today's topics with the topics which we are going to discuss in our today's video. Students, let's see which topics we are going to discuss today. First of all, very first topic which we will discuss in today's video, that is the rates of plate movement. As we know that during the time of the Pangea, around 200 million years ago, that time the plates started to shift to different direction, and every year these were shifted to the different direction, and after that they were changed into the continents and the oceans. So what is the actual rate, on which rate every year the plates are shifting? That is known as the rate of the plate movement, that we will study in the first topic. Then second, we will see the force for the plate movement. How many forces and which forces are responsible for the plate movement, that we will see in our second topic. Then in our third topic, we will see one plate movement of the Indian plate, where we will see how the Indian plates were shifted and were formed as a continent as well as the subcontinent, continent Asia and subcontinent India. So let's see our today's video with our first topic, rate of the plate movement. So let's see what is the rate of plate movement. We know that our Earth, which is rotating on its axis, just suppose that is our Earth and rotating on its axis, that is the north point and that is the south point, and that is our Earth. So here are few points which are known as the magnetic field stripes of our Earth. These areas of our Earth are known as the magnetic field stripes, due to which our Earth is having a magnetic field stripes through which we are getting the gravitational force and also the plate movement of our Earth. So these are rotating on to other direction, some are to the different direction, few are here, like that. These are known as the magnetic field stripes, and that is our Earth, which is rotating on its axis, due to which a gravitational force is occurring, and due to the magnetic field stripe on the parallel basis of our Earth, that is always on the parallel basis, the magnetic fields, and due to which a force is occurred on that, and due to which the plates which were earlier in the form of Pangea, these plates, now they started to shift it after the rotation when the earth started to rotate. So on that time these plates were started also to shift to the different direction, and then after that they formed the different continents as well, and due to which the earth get its rate of movement on the plates. But what is the actual rate of the movement of the plates? As we have studied many times that since a very long period earth is rotating and the plates which are above the asthenosphere are also shifting to the different direction, and the rate is around 1.5 centimeter per year to 5 centimeter per year, and that is depend on the basis of the thickness of the plate and the magnetic field which is nearby the plate, due to which the plates are getting their plate movement rate. Now let's see more about the rate of plate movement through some pictures where we will see the magnetic field of the earth and how it is responsible for the rate of the plate movement. So students, if you will see the rate of plate movement as you have seen in the video, the stripe of normal and reserved magnetic field that parallel the mid-oceanic ridge help scientists determine the rate of plate movement. These rates vary considerably. The Arctic ridge has the slowest rate, less than 2.5 cm per year, and the East Pacific rise near Easter Iceland. In the South Pacific, about 3,400 km west of Chile has the fastest rate of plate movement is around more than 15 cm per year. See our second topic, that is forces for the plate movement. Plates are moving, but how? Not obviously without force. So what is the force? What are the force through which the plates are getting their movement? So there are lots of forces after studied by Harry Hess and Alfred Wegener. They were having the different theory on the basis of the different forces which are responsible directly or indirectly behind the movement of the plates tectonics. Here the direct forces we can include the volcanic eruption which is occurring due to the high pressure, the earthquake movement, that is also a kind of force, temperature, climate and heat. Many types of forces are there behind the movement of the plates. So the main forces we can include: number 1, plate tectonic. Number 2, we can include temperature. Number 3, we can include heat. Here, heat is not equal to the temperature. Heat means the heat which is coming from inside of the earth. So, it can be included in the inner heat. Then after that, the drift. Weather is also responsible. In the weather, we can include the rain, the heat and the cold. How? Because due to the heat, the metal due to which the earth is formed, these are getting spreaded due to their speciality, or we can say their characteristics, through which the plates are also getting a kind of force for their movement. And also through the cold, when the cold is there or the weather is of the winter, and during that time the metal is going to be shrink, due to which the plates are also getting a different type of movement. Same like that, the water due to the rainfall is also helping to the denudation process, through which the plates are started to move. Now we will see these forces in detail with the help of slides and the pictures. If we talk about the forces for the plate movement, the slow movement of hot, softened mantle that lies below the ridge plates is the driving force behind the plate movement. In detail, if we will say, there are several forces behind the plate movement, which are also known as the thermal convection, movement of currents, floating of plates, hot spots of volcanic activity and volcanic eruptions. So first, the thermal convection. Already we have studied about the thermal convection, which is a kind of the thermal or the temperature of earth, inside or outside temperature, which is also responsible for the plate movement. It acts as a driving force for the movement of the plate. The second is the movement of currents. Hot currents rise and then cool as they reach the surface. At the same time, cool currents sink down. The convectional movement moves the crystal plates, and that is the responsible force, the plate movement. Third is the floating of plates. We all know the layer of our earth is divided into 3 parts, that is the crust, mantle and core. And below the crust, above the mantle, there is a layer which is known as asthenosphere, which is in the mobile form, or we can say in the semi-liquid or semi-solid form, which is a discontinued layer above which the crust is floating. The ridge plates of the lithosphere, which floats on more mobile asthenosphere, are in constant motion, due to which the plates are getting their force and they are moving to the different directions. Next force is the hot spot of volcanic activity. Small currents of past volcanic activity are often located far from any active plate boundary, suggesting the effects of convectional currents on the lithosphere. And these are also known as the hot spot, due to which the plates are getting the movement. Then next is the volcanic eruption. As already I told you, it's a direct force. The source of magma in the mantle remains fixed in position while the lithospheric plate above it moves steadily. In this way, volcanoes are formed over a hot spot, but they become extinct. These extinct volcanoes form a chain that is a record of plate motions. let's see our today's last topic, which we have studied several times. Even in 9th class also you have studied, and in the previous chapters of 11th class, in the second book also you have studied, might be in the first book we have studied a lot of time about Pangaea, Gondwana land and the movement of the Indian plate. But here we will see the movement of Indian plate in a detailed manner. So let's see our today's topic, that is the movement of Indian plate. So as we are studying about the formation of continents and oceans and also their distribution, so as we are living in country India, we must have to know about the formation of Indian plate. So how that plate was formed? See students, around 200 million years ago, the supercontinent Pangaea started to separated. It was changed into Laurasia and Gondwana. Most of the landmass was there on the Gondwana land, but it was in the separated form, and the big landmass was in Laurasia. So during that time one plate was there. Gondwana was the mixture of several plates, whether the Laurasia was a mixture of Eurasian and the North American plate. Here Gondwana was the mixture of South American plate, African plate, Indian plate, Australian plate and also the New Zealand plate. Where the Indian plate of Gondwana started to shift towards to the north direction, where the Indian plate around 71 million years ago, it was around 50 degree south to the equator. So if we will go through the picture, of 71 million year ago, it's our earth and it's the line of 0 degree equator. Somewhere here around 50 degree south, here the Indian plate was there. We will go through only the Indian plate. So it was here around 71 million years ago. Then it started to shift towards to the north direction. So there was a lots of time taken by the Indian plates to shift to the northern portion and to merge with the Eurasian plate, where around 55 million years ago it is shifted to the northern portion near around the Cbse, and the sea started to disappear during that time and was converted into the Indian Ocean. And then after that around 38 million years ago, now totally it is near around the equator, where the India which we are having right now, the current position of our country, that is around here, around 8 degree 4 minute, 8 degree 4 minute north. We are having the position of our country which was shifted to the north with the Eurasian plate, and that is the India now, the Indian plate now. And that is the India early, and that was happened around 10 million years ago. the current position of our country we got around 10 million years ago. Now let's see the movement of Indian plate in detail, step by step, with the help of videos and the pictures. The Indian plate or Indian plate is a major tectonic plate straddling the equator in the eastern hemisphere, originally a part of the ancient continent of Gondwana. India broke away from the other fragments of Gondwana 100 million years ago and began moving to the north direction. The Indian tectonic plate is located in the northeast hemisphere. It is bounded by 4 major tectonic plates. North of the India plate is the Eurasian plate. To the southeast, the Australian plate. To the southwest, the African plate, and to the west, the Arabian plate. Indian plate includes India and Australia. Northern boundary is along the Himalayas. It is the place of continental convergence. In the east, it extended up to Rokinoma Mountains of Myanmar. Eastern margin is spreading site. Western margin extends along Kirthar Mountains, Makiran Coast, and Sea Rift. The boundary between India and Antarctica is called Divergent Boundary. Till 225 million years ago, India was separated by Tethys Sea. About 200 million years ago, India started its journey towards north. India collided with Asia about 40 to 50 million years ago and caused the upliftment of Himalayas. About 140 million years ago, the position of India, it was around 50 degrees south latitude. During the movement of Indian plate, 2 events occurred in India. First event was outpouring of lava and formation of Deccan Plateau, and the second was subsidence of the western coast. Around 40 million years ago, there was a rising of the mountain Himalaya, and that is the movement of the Indian plate. Students, here the chapter Distribution of Oceans and Continent is complete. Hope you understood. In our next video, we will study a most interesting chapter, that is the minerals and rocks. And for that, don't forget to keep watching SST Joe.